Well, welcome everyone. I'm really pleased that you're able to join SEEK's seminar series and our distinguished faculty seminar series. Today, we're really lucky to have Dr. Melanie Malone join us. She's an assistant professor at the University of Washington Bethel School of Interdisciplinary Arts and Sciences. And really at the core of Melanie's research is examining how environmental problems arise from a combination of biophysical, institutional, political, and cultural dynamics, relying heavily on critical physical geography. So she's really like just a mainstream, succinct type person. And just as an example, she's been interested in how the methods and technologies that are used to improve the environment result in very complex socio-environmental outcomes, some of which are for the better and others that are for the worse. So for example, she's investigated how agricultural conservation management programs actually funded by the US Farm Bill policies actually result in land degradation and increased herbicide use. So how did she come to this? Well, that's an interesting story that she can tell us sometime when she has more time to talk about her personal life. But prior to her academic career, she spent a number of years as a geologist, actually cleaning up contamination at industrial and Superfund sites in the Portland, Oregon area. And this is where she became familiar with a number of environmental policy and remediation issues that affect the United States. Before I turn it over to you, I just want to ask if you would please, if you have questions as we go along, go ahead and jot them in the Q&A bubble, which should be at the base of your screen. And at the end of her seminar, I will be looking at those questions and asking her those questions on your behalf so that she can respond to those. So again, feel free to post those at any time in the Q&A. So without further ado, Melanie, I will turn it over to you.
Great. Thank you so much, Margaret. Appreciate that. So yeah, I am really excited to be able to talk with you all today, and those on the East Coast. We were just talking about how wonderful it is to be able to talk to so many people, you know, in a variety of places. So as you all know, probably based on the title, I'm going to be talking about some of my research in community urban gardens here in Seattle, where I am. I also have a colleague that I do research with in New York as well, in Brooklyn area. And we've been doing kind of a comparative study of different contaminants that we've been finding in community gardens and looking at how people are exposed. But there are a lot of different moving parts to this project. So I won't get to all the different moving parts. Just know that it's a very integrated project that looks at a lot of policy, a lot of kind of social and political things that are going on it, as well, of course, as the you know, toxicity that we see in gardens. So this first picture I love. This is from one of those moving parts that I was just talking about, and this is at Mara Farm in the Lower Duwamish Superfund site, which, if you don't know what a Superfund site is, it's an extremely contaminated location that's on the Environmental Protection Agency's list. And folks down there suffer disproportionate effects of things like asthma because of bad air quality. Water in the area is usually contaminated by industry and so forth. But this is one of my favorite farms down there, and has always actually been historically a farm site. A lot of indigenous folks have used this for farming. There's a great little timeline that talks about the story of people that have used it, and it's a really diverse location. I did a project with some of the community partners there in order to figure out how to keep air contaminants out of the garden space for some of the starts that they were growing. And we won a grant together so that they could get a greenhouse with filters installed that would filter out a lot of the nasty stuff that floats around in the air. And they were really excited about it. And so this is a picture from that day when they were starting to construct that hoop house and do some of the work there. And then, you know, just backing up to where this project started. So I am now 3 years into the project. This upcoming summer will be the 4th year. But for the past 3 years, I've been out collecting data with students, and that's who you see in these photos. This is actually from my CPG class that I teach, which is critical physical geography, that I'll talk here in a moment. So this project started with my CPG students, and they were out doing field with me from the get-go. And they were able to go out and, take soil samples, like you see them doing in the pictures. They were able to go out and interview folks. And then near the end of the course, they were able to go out and, think about all the different things that they had learned within these gardens, and really got familiar with, how a lot of the policies that they thought were happening in garden spaces actually weren't, and that, things aren't really well regulated, and learned a lot about how people get exposed to contaminants. And I was really fortunate to do the research with these folks, because they were just a really energetic group. They asked great questions and came up with a lot of great questions that I didn't even think about to ask the gardeners as well. And that's a really important part of this research project for me, is the educational component. So not only with my students, but my community partners. And I think because we were all simultaneously learning together, and the students were interested and the community partners were, in learning about how the students do it, it actually was a really great kickstart for the project itself. And a lot of people got interested in that way, and seeing how the students were learning about things, and the students telling them about their experiences in the class. And that research has continued on. These are pictures from this past summer. So I partner with a lot of different organizations. Some of the folks in this picture are from UW, where I'm at, but also from Doris Duke Conservation Scholars program that some of you might know. And we also go down to the Duwamish, like I was talking about. So that picture that's down there, at least on my bottom left, the people sitting in the chairs, is some of the students talking to youth in the Duwamish River Valley that live there, about their experiences doing science work. You also see people interviewing, and then taking samples, and doing lab work. So this is a really great project for both community partners and students to get involved in various ways. And they do a little bit of everything. So one of the things I always tell my students and like community partners is that there's a variety of things that they can do. And they all, especially if they're working for me, they get, drone experience. That's what we're doing in that middle photo, and I'm waving there. They learn how to sample, they get some lab time, and then they talk to people a lot. So it's really fun in that way if there's something that you're really into. And I mentioned that I do things with kind of a critical physical geography CPG lens, and I'll explain that here. So for those of you that are less familiar, its central precept is that we cannot rely on explanations grounded in physical or critical human geography alone, because socio-biophysical landscapes are as much the product of unequal power relations, histories of colonialism, and racial and gender disparities as they are of hydrology, ecology, and climate change. So, for me, I am very much a physical scientist, but I've always wrestled with these larger questions of critical theory and why people do what they do, how landscapes are formed. And so for me, looking at this, this project in that way has been very helpful, because gardens are very much formed by people, but also exposed to contaminants because of larger structural issues and things that are going on that they have no control over. So in that way, it really fascinates me. The other reason that I've taken a CPG approach to this is in thinking about toxicity itself and what it means, and how it has and hasn't been studied. And that's another reason that I really like CPG, because it asks all those questions. So one of the things I always say is that we're in urban gardens, and they're in very industrialized areas sometimes, and we're in a big city. It's not that people don't know that gardens are contaminated. They're very much actually aware that they're probably gardening in a somewhat contaminated space. It's that, weirdly enough, a lot of the environmental justice literature that talks about social justice and food justice, and actually acknowledges a lot of the contamination sometimes, doesn't actually explicitly talk about what it means to be gardening in a toxic space, which I find fascinating because there is so much environmental justice literature about how, especially people of color, are harmed by contaminants. And so that's a glaring space in the literature for me, and one that's not dealt with very well. And so I think it's really, really, really important to address it. The gardens that I do work in are places that are extremely diverse, high populations of people of color, high immigrant population, lots of languages spoken. In some of the gardens that I work in, there's literally 17 languages spoken. So there's a lot going on there, and a lot of exposure that can happen to when people don't realize that there were toxins in their spaces. The other reason that I use the CPG approach is because I like to think about power and how research is done and who's doing that and how that translates to lack of protection for communities. So someone like me doing the research as a person of color, as a woman, is asking probably very different questions than policymakers and other folks that have traditionally done this work, and kind of not thinking about all the cultural aspects of it and the legacies of contamination that are then inherited by people that are trying to use the space. And so this is a quote from Disparity Despite Diversity. It's an article by Kristen Reynolds, and it really nicely kind of sums up why I do this research in contaminated spaces. She says, yet as alternative food scholars and activists have increasingly pointed out, there is a distinction between alleviating symptoms of injustice, such as disparate food access or exclusion from movement leadership, and disrupting social and political structures that underlie them. Even the most well-intentioned initiatives may exist within and reinforce unjust systems. And without attention to the oppressive structures that lead to social inequities, urban agriculture may perpetuate or even reinforce the injustices that practitioners and supporters aim to address. Thus, while urban farmers and gardeners are important for many reasons and should therefore remain as permanent elements in cities, just how deeply they make changes in social and political structures of the food systems and by what means practitioners may do so merits deeper understanding. So again, I am very, for people doing urban gardening. It's one of the many ways that people that have been excluded from outdoors and nature can engage. And I think that gardens are wonderful spaces for food justice and everything. But I think that in a lot of ways, especially that exposure to toxicity can reinforce many of the environmental injustices that we see around health and what it means to be safe in the environment. And so that's where I'm really kind of taking this approach. And one of the other, there's a lot of different interesting things as I do this project and think about all the different ways that the problem is not addressed. One of them is that the EPA actually doesn't have any definitive standards for soil contaminant levels that reflect soil site conditions and management practices that are common at agricultural sites and for urban gardens. And so there are a lot of different screening levels, and I'll talk about that here in a second. A lot of different screening levels out there that are basically like safety levels or guidance for how much you can go over. And those are based on things like if you're in a residential neighborhood and your kids playing in the soil, or sometimes it's for an industrial space and so forth. But there's actually nothing particularly for urban garden sites, which I find fascinating because there's a whole handbook about how well known, that they're toxic, and the EPA knows about this and still hasn't made any actual regulations for those particular spaces. So I actually have to use other guidelines in order to kind of think about it. But I'm also trying to point out that we really need those guidelines. And as I mentioned, the EPA knows that there's a ton of garden spaces that are in toxic spaces like brownfields. So if you don't know, brownfields are sites where previous activities left contaminants with potential toxicity in the soil or groundwater. So, you can picture industrial places, but also think of places like old dry cleaning sites, old gas stations that have been reclaimed, Lots of different places that have chemicals. A lot of those are reclaimed for garden uses. And the General Accountability Office estimates that there's about 450,000 of those in the US. And those are really popular spots for gardens. And so, again, just thinking about all the layers of how it's weird that this hasn't been addressed, even though it's really known. And then there's challenges, you know, for community researchers like myself, but also for gardeners themselves too, that explains why people haven't been able to, you know, adequately address contamination in their garden. One of the biggest is cost. So some of my samples, if I do PCBs, which I don't often do because they're so expensive, cost $900 per sample. So a lot of my samples are in the like $100 to $350 range per sample. And I will do PCBs if I think that there's a particularly vulnerable population like children in the area. And so sometimes I do that, but it's pricey. There are also lots of knowledge barriers, like what to sample, how do I sample it, and who can I send this information to? And then there's also, you know, the screening levels themselves and the need for interpretation. So, you know, during the introduction, you all heard that I used to be a geologist at a consulting firm. That's how I actually became familiar with all these different screening levels and health guidance and all these different things and how to interpret them. But if you didn't have training in that and, you know, a PhD and all these other things, it's very, very unclear about how to interpret those and if they're good enough. That's the other thing too. It's like a lot of screening levels that are put out there, you know, by government agencies are not necessarily the ones that people of color or marginalized folks want or maybe think are safe. Right now in the Duwamish River again, there's debate about polyaromatic hydrocarbons, which is another type of contaminant that's out there. And the EPA is thinking about lowering their guidance so that, you know, they say it's not as toxic, and that's a big fight right now. So there's a lot to say around that I can't get into here, but just another challenge. There are also unknown sources of contamination that come into the garden, and it's usually very unintentional, but there's also a lot going on around us, even our air that, you know, deposits stuff down on us. And then always, once you find the contamination, what to do about it once it's found. And that's where I try to give more guidance and help people mitigate it from coming in the first place. And if you're wondering what I sample for, these are the main ones. So I know I just mentioned PCBs. I do that sporadically when I think it's needed. But for the most part during this project, I've done these three categories. The top one being total petroleum hydrocarbons, which are diesel, motor oil type products. A lot of people don't know that those can be in like your synthetic fertilizers and other pesticides and things like that. The gardens that I work in are organic, so theoretically they shouldn't be in there, but sometimes stuff sneaks in. So you do find that, but also again, there's like vehicular traffic that's around that can cause that. Heavy metals, these are really hard to get rid of, and I'll talk about that in a little bit more detail soon, but those are very, very common. And glyphosate, some of you might know like Roundup or Crossbow, those brand names, those have glyphosate in them. Number one used herbicide in the world. It's in all of our bodies. It literally rains down on us. USGS has all sorts of studies on this stuff. Probable carcinogen. Lots of bad news around glyphosate. So I've had a continuing interest in glyphosate because of my dissertation studies where I studied it in big ag out in rural areas. And so I look at it and unfortunately find it a lot in our urban gardens too, even though again, gardeners don't typically use it. And I talked a lot about the sources of where things come from. And people always ask me like, oh, I'm doing like everything I can. Like, how is it getting in? Well, a lot of the stuff I just talked about, like the vehicular stuff and how things rain down on us, but also people don't think about sometimes donations. So, you know, like you can see in that picture, they're like street sweeps where people collect leaves. Sometimes wood chips come from, places where trees have been sprayed with pesticides for things like ivy and so forth. Grass clippings might be fertilized. They might have other chemicals on them that people put into their gardens. If you use chickens or any type of animal, if what they're fed is not organic, pass through their system. And also things like kitchen scraps and so forth hold a lot of different residues of contaminants if you're not buying organic, which a lot of people cannot afford to do. So again, in no way is this a discussion of like what's right and wrong to do. A lot of the gardeners that I interact with rely heavily on food from their gardens and are just trying to get by and do what they can. But this is just to give you an idea of how things get into the garden spaces in general. So when I first go out to a garden space, one of the first things I typically do is take a drone shot of the location. And this is obviously useful for plotting where samples were taken, but also, as I'll talk about a little bit later, for looking at where contamination happens and thinking about what was in each individual garden box. So this is just a picture from our UW Bothell campus farm that we have, where I've taken samples, or I've taken samples and I've taken a drone photo to show that. The reason the image is red is because I actually have an infrared camera that looks at vegetation health as well, which I don't have time to talk about, but that's why you're seeing it in these shades of orange and red. And then on this screen, this is some of the results, at least for the metals and the petroleum products that I sample for the 3 past years that I've been looking at. So on that very left-hand column of all of these different tables that you're seeing, you see these different screening levels that are commonly applied to residential soils or in places where there are known contaminants. And then right next to that, I've got the number of samples that I sampled, which varies every year depending on access, funds, we had a pandemic, things like that. And then you'll see the number of samples that exceed that, as well as the percentage of the samples that are exceeding it. So it's been really interesting looking at different trends in the gardens themselves. So you can see in the 2019 table, the arsenic screening level for ingestion, meaning you're eating it somehow, like you're getting soil into your mouth. 82% of samples exceeded it, and in 2020, 94% exceeded it. It is really, really, really hard to get rid of metals in soil, and they tend to linger. And for arsenic in particular, it's really hard to get away from those numbers in our region because we had one of the largest smelters in the world in the late 1800s, early 1900s, the Tacoma arsenic smelter. So a lot of our soils naturally have high arsenic, but also were affected by that huge arsenic smelter. So it's really hard to get those numbers down. Sometimes we can get them lower. So even though the numbers are still exceeding percentage-wise, we are having some success in getting certain locations down, and I'll talk about that too in a second. You can see that the lead is still pretty high. When you look at the lead EPA, SSL, if you go down there, that's a soil screening level for that. Some of these don't have available screening level guidance. So that's something else that I talk about my gardeners with, because they're always like, what is safe? Like, how do I know? And I have a lot of discussions about safe, because I usually don't use the word safe. I just say we can do better. And one area that actually is getting better is the petroleum products. So the last line in all of those tables, or you see the DRO Washington Method A cleanup level. A lot of the different composts and soils that we're using had high levels in it in the first year. And I really talked to them about trying to get some of that down. So the next year, there actually wasn't very much. This year, we had a little uptick, 15% of them. So in thinking about, which locations have more, which compost and soils and so forth, we've been able to have a lot of good conversations about what types of compost and soils and so forth to avoid putting into the gardens. And this is just an illustration from one of the farms that I work at of how I give this information back to gardeners as well. So I give them status reports now every year. And this takes, a drone shot that I've overlaid onto a city map so that they can see where their samples were taken. So on the left side, you see the total arsenic and lead detections. And then on the right side, you see the petroleum hydrocarbons. And again, when I was talking about, like when we're looking at a specific locations, it's actually really, really helpful because the gardeners can tell me where they use different soil inputs. So, what type of compost did I use here? Did you allow kitchen scraps in? Did I use the local compost from, the site, or did I use it from a donation? It's really helpful and like playing with some of these areas and figuring out how to target them and think about how we can stop bringing the contaminants in. And I also always try to take a pure compost sample when they have a new delivery of something. So if it's a new compost or soil or something that they've used, I try to take a fresh sample as soon as they get it delivered to see if it's going to be good to spread or not. And we've actually had a lot of success with that too. Just quickly through the plant results. So the good thing about it is that I have not found any glyphosate detected in the plants, which makes a lot of sense because usually it will kill plants unless they're what we call like a Roundup ready crop or it's been genetically modified. And I only started taking, even though I've been doing this project 3 years, I've only been doing the plant samples 2 years. So this is like relatively new stuff that I'm dealing with. Like I'm very much venturing into new space because I'm primarily somebody that digs in the soil and knows soils. It turns out processing plants takes a lot more effort, but I'm glad that I'm doing it because the gardeners know they're getting exposed through their soils, but also they want to know what they're putting into their mouth the most. Another thing that I found was that there are actually very low levels of polycyclic aromatic hydrocarbons, which are PAHs. So I tested for them last year, but because they were in such low amounts this year, those things PAHs come from petroleum products and other things. And I was glad to see that. The less encouraging thing is that there are some concerning levels of arsenic, cadmium, and lead in plants. And if you're wondering what types of plants that I sample in, it's usually the stuff that uptakes a lot of the contaminants. So things like kales, collards, broccoli, carrots, potatoes, onions, beets, broccoli, cilantro, lettuce, and chard. And what I've been looking at as I've been analyzing the gardens is that a lot of the plants that are in these categories actually have the potential to exceed like your maximum daily intake levels that you're supposed to have of these different metals that were established by the FDA. That's very much dependent on how much you eat from the garden. So that's a good thing because you can mitigate it. But as I've talked, and I've joked with some of our gardeners, they're like, oh yeah, I'm doing a donation today. And they're like, but I'm going to have to say it's, only eat this much per day and so forth. And so they take it in good stride, but it is a factor in all of this. The more it's one of those things that is kind of hard to like suss out like what you should be doing and so forth. So I also look at trying to figure out what's going on with people's practices, as I was talking about, and especially looking at compost practice. So I've been taking a lot of different interviews and surveys and thinking about how to filter out some of the stuff coming in, as I was just talking about. So this is just an example from one of the years where I did it, where I asked people, do you use kitchen scraps in your compost? 42% don't, but over half do. And then when I ask people, are all the kitchen scraps you used labeled organic, you can see that the majority of people say yes. However, what I have found in combination of looking at surveys and the interviews, definitions of organic matter. So when I talk to a lot of the older folks in one of my gardens, it's primarily people that are like over 80 and 90, mostly Asian populations that have immigrated. They'll, if I say like what's organic, they say, oh, it's green. Like it doesn't matter if it's labeled organic or not. Other people will say similar things in other gardens too. But so there's a little bit of nuance to thinking about like if something is actually organic or not. Also looking at animal waste and human waste. So the majority of people don't use it, but if they do use it, it comes from a variety of different places. So some people know it's organic, some people are not sure, some of them do know and so forth. So there's a variety of things going on there too, and me thinking about, how things get into the garden. And because I know where I took that space and who took the survey, then I can kind of do some, detective work and thinking about, what might be bringing in a contaminant. This is just an example of some of the compost that I've sampled so far. This year, there were actually quite a few more that were being used than last year. And I'm able to give these in those status reports I was talking about before to gardeners and talk about, which ones are good and which ones are bad. Looking at things, like the arsenic compost in their soil and giving them those levels and talking through with them what that means. And I also put on, the screening levels that I can apply, even though, as I said before, we don't have anything specific for gardens themselves. You can see in this graph below, this is another arsenic graph with the different composts and the different screening levels. And most gardens, as I was talking about, exceed that arsenic level for ingestion. So it's, again, really difficult to get away from that. Then as you go into some of the less restrictive things, like your dermal contact, like you're touching things, not as many do. The background for Puget Sound for arsenic, not as many do. One of the things that I try to do every year is show like which garden compost is the best one to use if gardeners want to switch it out. And some of my gardeners already have. So one of the composts I found here in Seattle, at least, was Green Blends compost, which had no petroleum products at all and very like the lowest levels of arsenic and lead I've ever seen. Like actually, I would be comfortable saying like I wouldn't worry about it. So that's one good way for me to be able to intervene and tell people the different type of stuff to use. Not everybody has that privilege. As a lot of you know, gardeners can be strapped for money and time, and it takes a lot of labor to switch out things. So these are just some of the factors to consider. And then in this, this is actually a community generated question where people were really interested in how their garden produce compared to grocery produce, which I was like, oh, that's a cool thing that they want to know. So as it turns out, there's not a ton of studies that show, different types of produce. I was able to find 4 different ones from, San Francisco, Florida, from the FDA. There's an FDA site that takes it from 4 different states, but they don't tell you where it is. I'm sorry, that's actually USDA, not FDA, and a few other things. And I was able to get that accumulated data for different types of, grocery produce. And then, so those are usually the bars that I have here in the gray. So anything that's gray is from some other study where they've looked at the levels. And then anything that's in black is a sample that I've taken from my gardens. So these are just 2 graphs, but the unfortunate trend that I've noticed in a lot of my gardens is that the produce coming from the organic gardens that I study in are oftentimes higher than what's shown in those studies. So sometimes, these are the unfortunate results, but it's also interesting too. And thinking about like, why is that? And, some of the groceries are organic, some of them are not. So still thinking about that and, why we're seeing those trends. Um, the other thing that is helpful though, is that with things like cadmium and lead, you really can, think about how much you're eating of each plant. And so I make a lot of recommendations based on how much a kid is eating. And this is based on what FDA has recommended as far as like what kids normally eat out of their gardens and so forth. So there are different recommendations for lead, like down in there in the red circle. They don't recommend, over 3 micrograms per day. Cadmium doesn't have a level, although there's other studies. And so I have those in my status report. I believe it's around 4.1 or so from California studies. And so based on how much the kid's eating out of the garden, then I have a calculation in the status report that tells gardeners how to, calculate it. It's set up very easy. So they just plug in a number and they know, like, if I eat like a quarter of a pound of carrots per day, then my kid will be okay or not okay based on the contaminant levels that I found in the garden. So this has actually been fun, even though the original thing that they asked me to do, didn't have like, happy results, but this is another way to like mitigate how people might be exposed, especially their kids. And then this is just another slide on that, on how there's too much cadmium and lead in kids' foods. One of the things is that goes along with this is that I'm finding that like the science communication part is super critical for this. So I don't want to turn anyone off gardening, and so it's really, really important to like convey how how much you eat translates to how much you're exposed to or how long you're in the garden and so forth. This is the trickier part of when I'm dealing with different municipalities because they're worried about liability and other things, as where my interest is really in giving people the information. And if they eat it, fine. That is totally up to them, because I'm not going to tell people what to do and what not to do. But I think they should have the right to know as well. So this has been good. And just wrapping up here too, there are just so many other moving parts to this. So as I was talking about, that science communication part is really key. So I still every year do tons of interviews and workshops. This year was a blast because everybody was back, even though both years I think people were gardening even more because they were, finding that they wanted to be outside and doing something when there were limited options in the pandemic. But continuing to think about what people's environmental justice concerns are, especially as the project evolved, has been really interesting, and seeing how people are changing their practices and like bringing this stuff to the attention of municipal authorities and changing their grants so that they actually test for their soils has been a wonderful experience. And just thinking about the power dynamics in that and like giving people agency to address these things has been really cool to see. It's also been really cool to see my students get involved in different organizations that I work with and community partners that I have. So we continue to do that. And just, kind of as my soapbox of, like how, anybody doing this work should address it, and think about it. One of my big points is that communities need more resources, financial, scientific guidance, labor, in order to sample and keep people safe. Environmental justice in community gardens obviously needs to include sampling for contaminants. It can't just be about access to food. Here in Seattle, we have a racial equity toolkit to analyze the racial impacts of policies and programs, but Seattle doesn't do very much testing at all for contamination. I'm like the only person out here that does it and works with the community groups to think about it. So that's another big gap. And then just stating the obvious, people shape the environment, but obviously the environment shapes people too and can affect their public or their health and a lot of other things that are going on in those situations. And I'm just really fortunate to have really good community partners that have been on board with this project. We do a lot of fun things together, and a lot of things that are there to like educate youth and give them different opportunities to engage with their partners in various ways. We've won a lot of different grants together, and I've been really happy, especially because this topic can evoke a lot of emotion. So where I'm going from here, still thinking about what places are the most contaminated. I offer a lot of different suggestions for different people that are working in the spaces. You know, some people, once they find out that it's contaminated, they think, oh, just, put flowers or plants in. Sometimes I tell them certain plants to put in to intentionally take up contaminants if they want to go that route. There's a lot of community remediation projects through our grants that we've been doing. So like trying new soils, I mentioned the greenhouse, doing some microremediation fungi, and then always just talking to each other about how to make things better, but also pushing municipalities to test for the contaminants in the spaces and doing it in equitable ways. And this is all done, with the free, prior, and informed consent, and working with the community and not on is like one of my big kind of mantras. So really, really important stuff. And I also think that, this project has been meaningful in a variety of ways for the students that I've been working with. We really diverse population of students on this campus that I'm really glad and bring a lot of to have and bring a lot of perspective. The fact that they get so many different skill sets on the project is rewarding because I can teach them how to do it. And then they also can transfer that into careers or other things that they want to do. And it also translates, like citizen and community science that is really popular, but I think necessary to do this type of research, and goes along with, kind of the CPG lens that I take to it. So lots of good stuff there.